Hello my dear friends, I hope you are all fine and preparing for the CET examination that is fast approaching. So in this class we shall discuss some MCQs on the solution that is in the 12th standard, and here are the questions. Which of the following relates the concentration of solution with the relative lowering of vapor pressure? A. Mole fraction, B. Parts per million, C. Mass percentage, D. Molality. Difference. The equation that relates a concentration of solution with the relative lowering of vapor pressure is this one: P naught minus P divided by P naught, that is equal to N2 divided by N1 plus N2. So in this equation, P naught is the vapor pressure of the solvent in the pure state and P is the vapor pressure of the solvent in the solution. N2 is the number of moles of solute and N1 is the number of moles of the solvent. So the relative lowering of vapor pressure is equal to mole fraction of the solute. Therefore, the correct option is the option A, that is the answer. We should take next question. Maximum amount of solute that can be dissolved in a specific amount of a given liquid solvent does not depend on A. Temperature, B. Nature of the solute, C. Nature of the solvent, D. Pressure. Dear friends, the maximum amount of solute that can be dissolved in a specific amount of the given liquid does not depend upon the pressure. So the correct option is the D option, that is pressure. The amount of solute that can be dissolved in a specific amount of a given liquid depends upon the remaining three, that is temperature, nature of the solute, and nature of the solvent. So if temperature increases, the solubility of solid increases. If it is a gas, the solubility of gas in the liquid decreases. And definitely the amount of solute that can be dissolved in a specific amount of given liquid depends upon the nature of the solute and nature of the solvent. So the correct option is the D option, that is the correct answer. Now we shall take question number 3. The concentration of oxygen in the blood and tissues of the people living at higher altitudes is low due to A. Low temperature, B. Low atmospheric pressure, C. High atmospheric pressure, D. Low temperature and high pressure. Dear friends, you know that the solubility of the gas is depending upon the pressure. When pressure of a gas is more, the solubility will be more, and when pressure of gas is less, the solubility will be less. That means solubility of gas is directly proportional to the pressure of the gas. So at higher altitudes, the pressure will become less. Okay, so at higher altitudes, the partial pressure of oxygen will be less than that at the ground level. Therefore, the solubility of gas in liquid is less at low pressure. Hence, the correct answer is the option B, that is the low atmospheric pressure. Question number 4. Which of the following mixtures show positive deviation from the Raoult's law? A. Methanol and acetone, B. Chloroform and acetone, C. Nitric acid and water, D. Phenol and aniline. Dear friends, here the options B, C and D are the solutions which show negative deviation. Only the correct answer is the option A, that is methanol and acetone. Methanol and acetone, when mixed in adequate proportions, form minimum boiling isotropic mixture, and hence it shows the positive deviation. So the correct answer is option A, methanol and acetone. Okay. Question number 5. Colligative properties of the solution depend on A. Nature of the solute particles, B. Number of the solute particles, C. Physical properties of solute particles. D. Nature of the solvent particles. Dear friends, the qualitative properties depend upon the number of solute particles, not on the nature of the solute particles or the physical properties of solute particles or the nature of the solvent particles. So the correct answer is option B, number of the solute particles. Now we shall take question number 6. Which of the solutions has a higher boiling point? A. 1m NaOH, B. 1m Na2SO4, C. 1m NH4NO3, D. 1m KNO3. Dear friends, in the given options, all the solutions are having the same concentration, that is 1m or is 1 molarity. So the boiling point depends upon the number of ions that is produced by each one of these solutions. If it is producing more number of ions or the particles, then there will be a rise in the boiling point, and that solution will have the higher boiling point. So in the first option, NaOH will dissociate to produce two ions, that is two particles. And this in the second option, Na2SO4, that is sodium sulfate, it dissociates to produce two sodium ions and one sulfate ion, that is totally three ions or three particles. In the third option, ammonium nitrate, that also produces two ions, NH4 plus ion and NO3 minus ion, two ions or two particles. KNO3, that dissociates to give two ions, K plus ion and NO3 minus ion. Therefore, here second option, Na2SO4, is one which produces more number of ions or the particles, so that solution will have the higher boiling point. So the correct answer is B, option, that is 1m Na2SO4. It has high molecular mass and it dissociates to give three ions. Now let us take question number 7. The unit of a ebullioscopic constant is A. Kelvin kg per mole, B. Mole kg per Kelvin, C. kg per mole per Kelvin, D. Kelvin mole per kg. Dear friends, the correct answer is option A, that is Kelvin kg per mole. Next, question number 8. In comparison to a 0.01m solution of glucose, the depression of freezing point of a 0.01m MgCl2 solution is A. Same, B. About 3 times, C. About 6 times, D. None of these. Dear friends, the depression of freezing point is one of the qualitative properties, so that depends upon the number of particles. If you consider 0.01m solution of glucose, so glucose is actually the covalent molecule, it will not ionize, so one glucose molecule is considered as one particle, whereas the 0.01m magnesium chloride solution, that is a magnesium chloride is the ionic compound, it will dissociate to give three ions. There is one magnesium ion and two chloride ions, and both these solutions are having same concentration. So only thing is the glucose molecule is one particle, it will not dissociate, and magnesium chloride is an ionic compound and it dissociates. So the number of particles produced by magnesium chloride is 3, whereas the number of particles produced by glucose is only 1. So the depression of freezing point of the 0.01m magnesium chloride solution is about 3 times. So the correct answer is option B, about 3 times. Now we should take next question. Question number 9. An unripe mango, when placed in a concentrated salt solution to prepare pickle, shrivels because A. it gains water due to osmosis. B, it loses water due to reverse osmosis. C, it loses water due to osmosis. D, it gains water due to reverse osmosis. Dear friends, when the solutions are separated by the semi-permeable membrane, the solvent molecules will move from lower concentration to higher concentration. So here mango is placed in a concentrated salt solution. So in that case, the solvent molecules will move from lower concentration to higher concentration. Therefore, the correct answer is option C. That is, it loses water due to osmosis. Solvent molecules move from lower concentration to higher concentration. So, it will shrivel because of the loss of water due to osmosis. Now we should take next question. Question number 10. At a given temperature, the osmotic pressure of a concentrated solution of a substance A is higher than that of a dilute solution, B is lower than that of a dilute solution, C is same as that of a dilute solution, D cannot be predicted. Dear friends, the osmotic pressure of a solution is actually directly proportional to the concentration of the solution. If the concentration of the solution is more, then the osmotic pressure will be more. If concentration of solution is less, then osmotic pressure will be less. Therefore, the correct answer is option A, that is higher than that of a dilute solution. As osmotic pressure is directly proportional to concentration of solution, the osmotic pressure of a concentrated solution at a given temperature is higher than that of a dilute solution. The correct answer is option A. Question number 11. The values of Van 't Hoff factors for KCl, NaCl and K2SO4 respectively are A 2, 2 and 2, B 2, 2 and 3, C 1, 1 and 2, D 1, 1 and 1. Difference: the values of Van 't Hoff factors are given by the number of ions or the particles produced by these substances. KCl dissociates to give two ions, K plus and Cl minus ion. NaCl also dissociates to give two ions, Na plus and Cl minus, whereas the K2SO4 ionizes to give two potassium ions and one SO4 2 minus ion. So the correct answer is option B, that is 2, 2 and 3. Question number 12. The value of Henry's constant Kh. A. Increases with increase in temperature. B. Decreases with increase in temperature. C. Remains same. D. First increases and then decreases. Dear friends, according to Henry's law, at constant temperature, the amount of gas dissolved in a liquid is directly proportional to partial pressure of the gas above the liquid. Therefore, as temperature increases, the value of Henry's constant also increases. The correct answer is option A, that is increases with increase in temperature. Now we shall take question number 13. There are three aqueous solutions of NaCl labeled as A, B and C with concentrations 0.1 m, 0.01 m and 0.001 m respectively. The values of Van 't Hoff's factors for these solutions will be in the order A less than B less than C, B option, A more than B more than C, C option, A equal to B, B equal to C, D option, A less than B, B more than C. Dear friends, here the Van 't Hoff's factor again is nothing but the number of the ions or particles produced by the different concentrations of the sodium chloride solutions. So here A is having a higher concentration than B, B is having a higher concentration than C. So since C is a very much a diluted solution, so the ionization of sodium chloride will be more in the diluted solution than in the concentrated solutions. So the correct answer is option A less than B less than C. Okay. As dilution increases, the degree of dissociation of NaCl increases. As a result, the number of particles increases and Vent-off factor is proportional to the number of particles, which increases from solution A to C. Therefore, the correct answer is option A, that is the Vent-off factor for A is less than that for B, and Vent-off factor for B is less than that for C. Okay, now we shall take next question. Question number 14. 4 liter of 0.02 m aqueous solution of NaCl was diluted by adding 1 liter of water. The molarity of the resulting solution is A 0.004, B 0.008, C 0.012, D 0.016. Dear friends, for this type of problem we have to use the formula M1V1 equal to M2V2. So let M1 and V1 be the molarity and volume of solution respectively before dilution, and M2 and V2 be molarity and volume of solution respectively after dilution. That means M1 V1 should be taken for the solution before dilution, and M2 V2 should be taken for solution after dilution. So here M1 is the molarity of solution before dilution, that is given to be 0.02 m, and volume of the solution before dilution is a 4 liter, that is a 4L. So V1 equal to 4L, and the molarity of solution M2 is required to be calculated for solution after dilution, and V2, the volume of solution after dilution, will be 5 liters, that is initially 4 liter, and we are adding 1 more liter, so that total volume will be 5 liter. So V2 equal to 5 liter. So use this formula M2 equal to M1 V1 divided by V2. So here V2 is taken to the denominator of the left hand side term. So M2 equal to M1 V1 divided by V2. So M1 is 0.02 and V1 is a 4 and V2 is 5. So therefore 0.02 into 4 divided by 5, that will be equal to 0.016 m. So the correct answer is option D, that is 0.016 m. Next question. Which one of the following is an isotonic pair of the solutions? A 0.15 m NaCl and 0.1 m Na2SO4, B 0.2 m urea and 0.1 m sugar, C 0.1 m BaCl2 and 0.2 m urea, D 0.2 m MgSO4 and 0.1 m NH4Cl. Dear friends, isotonic pair of solutions are those which have same osmotic pressure, and this solution will have same osmotic pressure if the number of particles are same. Okay. Now the number of particles can be obtained by multiplying the concentration and the number of ions or the particles produced by dissociation of these substances. Okay. The product of the concentration and number of particles should be same for these isotonic pair of solutions. So whichever pair has the same product of concentration and the number of particles, then that pair will be having the same number of particles, and that will form the isotonic pair of solutions. Okay. Now if you see that the correct answer is option A, that is 0.15 m NaCl and 0.1 m Na2SO4. Dear friends, NaCl will dissociate to give 2 ions, that is 2 particles, and the concentration of NaCl is 0.15. So 0.15 into 2, that will give 0.3, and Na2SO4 will dissociate to give 3 ions. So 2 sodium ions and 1 SO4 2 minus ion. So number of particle is 3 and concentration is 0.1. So 0.1 into 3, that will be 0.3. So both will be having same number of the particles. So that correct answer is option A, 0.15 m NaCl and 0.1 m Na2SO4. Okay. So thank you very much for being with me in this video. Wish you all the best of luck. If you liked this video, please share with your friends and subscribe the channel. Thank you very much.